All right, well, hello everyone. This is Chris from NextPCB. A few years ago, I had written a blog post specifically about counterfeit components. And obviously a few years ago, nobody knew that 2020 was going to be the year that it was, and obviously nobody knew 2021 was going to be the follow-on to that. And so some of the things that I said in that article tended to be a little bit prophetic. It wasn't by nature, it wasn't designed that way. But what we found in this last year is that the supply chain and the disruption and the subsequent challenges that have come from the supply chain have caused a lot of the abnormalities that I described in that article. So I'm sure we'll link that at some point around the video where you can see it. But I wanted to talk with you guys a little bit today about what we're seeing in the supply chain and what we're seeing in the overall market and things you should really be careful for because we're starting to see more and more of the types of scenarios that I talked about in that blog post. So first, I want to talk through some of the issues, and then after that we will go over and we'll look at what some good and some bad components look like. So first, what are the challenges that we're starting to see in the supply chain? So current supply chain issues, many of you have probably read this in the news. You've seen auto manufacturers starting to close down some of their factories. They're starting to have to do some of the things that they would do when they don't have enough parts, they don't have enough supplies, they don't have the ability to keep a manufacturing line fully operational. So what we're starting to see is chips in the market, there's less of them. Why is that? Well, because earlier last year, when we saw shutdowns start to happen in factories all over the world, we started to see backups. We started to see that some of the components that were being supplied into the market slowed down. And at the same time, we started to see an uptick in consumption. We started to see an uptick in what people wanted. So we had more and more demand side pressure, and then we had less and less supply side inputs. And so now what we're starting to see is some of the end result. So less manufactured parts are starting to give us obviously less supply. And so what we're starting to see especially is many of the chip companies that are making some of the higher tech and more important chips in the supply chain, these are what are called fabless, by the way. They're fabless chip manufacturers. So that seems like it should be a bit of an oxymoron. But what happens is many of these chip companies that make some of the most advanced chips, they really just design those chips. And then they outsource the manufacturing of those chips to large-scale fabrication companies such as Taiwan Semiconductor, TSMC, here in China, Shanghai Semiconductor, SMIC, or you start to see Global Foundries, or some of the other big companies that do manufacturing. But obviously, they're getting order upon order upon order upon order from their customers, and they only have a certain amount of capacity. Now, obviously, we're seeing capacity being added and much more to come, but it takes a long time. So we have less manufactured products. But in the vein of what I talked about with the counterfeited components, we're actually starting to see more recycled components come into the market too. Now, I use quotes to say recycled because really these things are either taken from another source or they're actually fake. These are actually not real products that are coming into the market. So we're starting to see more and more of this show up. Now, why is this? Well, because lead times are huge. So as you start to see more and more orders show up, what used to be last year for us maybe a 16-week lead time or a 12-week lead time, now we're starting to see anywhere from 36 to 52 weeks. Now, it doesn't take a whole lot of math to figure out that's a lot more than it used to be. And most customers of ours and most customers that are supplying components, they will have had a production plan. And most of the time that would have been dependent upon the lead times that they expected for their components. So if they were expecting a 12-week lead time or a 20-week lead time, they would have planned their production accordingly. But some of these supply lead times have gone up quickly, very, very quickly, to the point where there was really no way to plan. And so it's starting to impact people's ability to deliver. And it adds an additional amount of pressure because some of these component manufacturers want some kind of payment up front. Right, so you would have paid before, you would have paid a certain amount of money to secure supply. And then in 12 weeks, 24 weeks, whatever that would have been, you may have had that amount of cash or that amount of capital tied up. And so you would have planned your cash flow accordingly. And especially if you have any kind of terms or credit conditions where your customers are not paying you as a manufacturer of an end product for a certain amount of time, then it causes cash flow crunches. And so we start to see more and more challenges of our end customers with their cash flow. And then of course that causes issues with the CM's cash flow, which then causes issues for, all sorts of challenges for everybody's cash flow coming through all the way through. So we're expecting this to really be the case for the rest of this year. Our supply chain people are telling us that we expect to see this type of disruption in our supply chains until at least December 2021. In fact, many of our customers now and our chip suppliers are even starting to say, hey, what are you thinking about 2022? And we have to actually start thinking about orders for 2022. So as a side note, for anybody that's thinking about producing the rest of this year, 2021, and into 2022, you may need to actually start thinking about your even first and second half of 2022 now so that you can secure supply. So I talked about recycled components. What does that mean? So recycled components, really, we're talking about very high value components most of the time. And these are very, very profitable components. These are components that are generally very expensive per unit. We have some products where you can easily see a single chip be 50, 60, 100 US dollars or more for one chip. And so when you start to see numbers like that, then the temptation to try and put something else in the market that can capture that kind of demand is very high. So it may seem like when you say recycled, in this day and age, when we start talking about sustainability, we start talking about conservation, recycled sounds really good, right? Well, in some things, but not when we start talking about electronic components, and especially sensitive, high-value electrical components, right? Why is that? Well, because there's a certain way that these components are delivered, and we'll talk about this in a minute. But much of the way these components are manufactured is in a very clean environment, dust-free, static-free, right? So there's ways that these components are manufactured, the way that they're packaged, the way that they're stored, and then even when they're removed from their packaging, that process with which they're removed and with which they are mounted onto a PCB, and then even assembled, and then all the way to the end user, there are very careful processes that are used in order to make sure that these components are kept, viable and are functional. Well, what happens if those components are then reused? Well, obviously, a lot of the processes that are used in the manufacturing have been undone in many ways for the components that you would see that have been recycled. So you start to see much higher failure rates, right? So maybe these components have been used for a long time. Maybe their duty cycle was only a certain amount of time, and you start to see those things happen more. Now, one of the other failure rates we start to see is, for example, at SMT, when we send these things through. So if for some reason some recycled parts or some not new parts have been put into an SMT, they won't adhere. You actually start to see that when they are put onto the board and they go through reflow, they don't actually stick. The flux doesn't actually stick. And so you start to see components that don't stay, on the boards. So you start to see very high failure rates even in the manufacturing process, let alone when they get out into the field. And so it's very hard to figure out in many cases, why is that the case? So if you think your components are new, but you start to see things happen either at SMT, or you start to see things happen in production, or you start to see abnormalities and higher failure rates in the field, why was that, right? So obviously it's very hard to pin down exactly where that came from when you're using recycled components. So you start to have to say, okay, what does a good component look like? What does a bad component look like? So, well, maybe we'll go over to the table over here and we'll take a look at what a good component looks like and what a bad component looks like. So if you walk over here, we've set up a little session here so that you can see what these components look like. So first, let's start with good packaging. So here I have a brand new box. I say brand new. It came in, maybe a few weeks ago here from ST Micro. Right. So first thing that you see here is that the outer packaging is original packaging. It's clear. It's nice. You can see, everything's packaged well. Has the proper labels. We'll talk about why this label's a little bit torn in a second. But when we open the box up, we see it is properly padded and labeled. Right, so one of the reasons you see the label here is torn, when we bring something into our supply house, we actually take the part of the label and we store that, we file that, and then we put on our own manufacturing control label. So this allows our stock room to know that we have brought something into our stock and that we have taken it in and we're storing it correctly, and that it's in our stock house. So if we take this out, you'll notice very quickly that this bag has, as I said, it has the label. It has obviously our control label as well. But you'll see on the packaging that what is the life out of the bag. You'll see, the normal markings that you would see for a package. You can see that this is very, very well vacuum sealed. The packaging has obviously been put through a process that makes sure that there is no excess air or moisture inside. And so you can really tell, with this packaging, you can see the trays outline, very good packaging, right? But again, the big deal here is that the label is original, right? So this label has the part numbers, has the trace codes, has the markings, tells us whether it's RoHS compliant, all the different things here, and these should match the outer box. So the box that we had a second ago would have these same numbers on them. These should match. And they should also match the lot numbers that you would expect to see from your distributor. So the distributor will tell you what lot number did these come from, what was the date of manufacture, and you should be able to verify all of the information on the label with what is on the outside of this box. So these are good packaging. Now, for not so good packaging, we have this package here, right? These are actually inside, these are LEDs, but you can very quickly see the difference between this packaging and the other packaging. One of the things that you see is there's no labels, right? There's no labels of any kind on this packaging except for ESD, right? And the warnings about the actual box, or the actual packaging. So what we see here is very little in the way. We really actually don't even know what's in this bag at all, based upon the outer packaging here. So this should be an immediate warning sign, that there are some things going on here, that are maybe not completely what you expect. So what are some other warnings? So we can open this one up. One thing you see here, it doesn't have a notch, so there's nowhere to actually tear this bag. Many of the manufacturers will actually have a notch that will tell you exactly where it is appropriate to open the bag and where it's not. And so this one, we're just going to hope this edge that has nothing in it is an appropriate place to pack. So we will open this bag up, and we will see inside. I think I opened this upside down. What we see when we open the tray here, again, this packaging style should be very, very telltale, right? You would not see masking tape being used to hold together the trays, if these are original components. All right, so we have this opened up here, and actually one of the first things that we can see here is that luckily all these components seem to have the same part number. The printing seems okay, but what you'll see many times for chips that are counterfeit is you may actually see that there are some abnormalities with the printing. The printing may not be as clear as you expect, right? And so, if we take one of these chips here and try to extract it without damaging it, right? So this particular chip, it's very hard to see here. We'll actually show some more close-up pictures here. But what you can actually see with a close-up is you can see that some of these pins actually are not smooth. Some of the actual mounting pins are not fully smooth, and you can actually tell that they've been cleaned. And so that they have been mounted already, and they have been cleaned. And so we can actually tell by secondary inspection of this particular chip, we can see that this has been recycled, right? That this chip is actually not original from the factory. And so again, we'll show some pictures of that kind of at an inset. But again, there's some definite telltale signs here that these chips are not original from the factory. So again, there's just some things that you can see whether they're good or bad. So it's very important that you do your inspections. It's very important, that you know your supply chain, that you know where these things are coming from, and that you know what you're looking for when you do receive components. So there's different types of components, obviously. These components are active components, but if you start talking about resistors, capacitors, it may seem like those may be okay, because obviously their tolerances are a little bit different, but our opinion is it's definitely not worth it, right? Even though resistors and capacitors may seem cheap and, to get recycled ones may seem okay, the quote we got from our supply chain and our electrical engineers is avoid them at all costs. Do not use, recycled components. So where do these come from? So I alluded to this earlier, but obviously there's tons and tons of electrical waste, that happens on a regular basis, and many components and many supplies, part of their life cycle is that they're going to be disposed of. So what ends up happening is, a lot of these boards are disposed of, and they are sent to places that will tear them down so that they can be either recycled or they can be disposed of in an ecological friendly manner. But in the process, a lot of the chips that are taken off are undamaged. They can actually be removed. And so even in our shop here, we do repairs, right? So a lot of the products that we make here are very, very high value. And so it doesn't make sense to just dispose of the entire thing. Many times what we will do is we will get if there's something damaged in the field, or if there's any challenges with a particular product in the field, it will get sent back to us, and we will do repairs, or we will do other types of rework, to be able to make the product usable again. And then a lot of our customers will use that as either warranty replacements, or they'll use it for test units for their engineers. So we do rework. And so the components can be removed, and they can be soldered back onto the new components can be soldered back onto the board, without a tremendous amount of hassle. So if these things can be removed, obviously if they're removed in bulk, they can be harvested and they can be put back, into the supply chain. And so what we see happening is that when large amounts of specific components are harvested, they can be actually put into back into the supply chain. They can be sold to one party, and then after it changes hands a few different times, the provenance of these chips gets lost. And so we've actually had situations where our suppliers that have good reputations have actually, been able to sell these chips as new because the provenance wasn't able to be verified all the way through. And so obviously when we get them, we do the checks of provenance, and we figure out, hey, these things are not what they're supposed to be. So how do you fix this problem? What do you do to make this better? So there's a couple ways to look at these solutions, right? Obviously, one of them focuses on finding bad components, but what's the better thing to do is put yourself in an environment where this doesn't happen to you. So from a supply chain discovery perspective, if you're locked into one single part, obviously that's not the best scenario. So being able to have alternatives to specific parts that may be in high demand is very important. Some types of chips will have multiple models. They'll have multiple types of production runs, or they may have possibly slightly different designs or different instruction sets. And so if you can expand out the types of components that you can use for specific purposes, then you can help to mitigate some of the supply chain challenges, and you can be more selective about the chips that you accept. Another thing is having a multitude of different suppliers. So we have literally hundreds of suppliers for components that we call upon to be able to send us what we need for our customers. And so being able to find the supply at the right time is very, very important. Which brings us to market access. Right, one of the things I said over here is that when these lead times get very, very high, obviously you can't order directly from the original factory if you've got supply requirements that are near term. So you need to go into the spot market. You need to be able to go into the market and try to see if there's components that are available. They may be at a much higher price than ordering them directly from the factory, but at least you're able to say, okay, I can get some components, I can sell something to my customers. So having market access is very, very important. And this is one of the things that NextPCB does to add a lot of value to our customers, because our supply chain people are working day and night to try and find the right components at the right time for our customers. They maintain good relationships with our suppliers. They spend lots and lots of time in Shenzhen, in Shanghai, and all the different places where we can go find components. They spend time in those places building relationships and knowing the people that have these components. And not only have the components, but be able to have them in stock or have places that they can go to go find those components. So that can help mitigate some of the challenges you have with lead time if you have very specific needs or very specific issues that you need to meet demand for your customers today. But if you find yourself in an environment where you have to start buying components from an aftermarket where you're not very sure about what you're actually going to be able to get, we'd say this, right? Identifying bad components, right? First, look at the packaging, right? I showed you guys a minute ago at the table, right? You should be able to very clearly see what's the packaging. Does it look like original packaging? Is this something that I would expect from a Texas Instruments or an ST Micro or a U-Blox or an NXP, right? Is this what I really expect from these types of organizations, right? Is the package worn? Does it look like it's been thrown out the window and then brought back upstairs and dusted off, right? Does it have its humidity card inside, right? Can you see that it's been stored correctly? What we've actually found lately is more and more components that are very old are starting to show up. I mean, even last week, we had a specific set of components that we were looking for, and somebody said, hey, I have some. And we asked the lot code, and the lot code was like 2011. And so that had to be a very difficult conversation, right? Because we have the components, we can find them, but are components that are 10 years old of this particular type going to be viable in the product that our customer was trying to sell? And so we had to think very clearly with them, about what are the implications. Should we get these components? Should they use them? And then how can we validate that these are still good and that they have been stored well for that amount of time? Right. When you look at the components specifically, if you've taken possession of them, right? I mean, it seems like you shouldn't have to say it, but do they look new? When you open the packaging, do they look new? For example, if you see any flux on the surface, obviously these are not new, right? Because new components that are coming out of their fab are not going to have flux on them. That means they would have been mounted in some way, shape, or form, right? Are the silk screens clear, right? Can you actually see what the part number is? Can you decipher specifically what part you're getting? And so these are all kind of telltale signs. I mentioned some of these in my blog post a couple of years ago, and it may be a good reference for you to go back and look at. But really the net here is we're in a bit of a new world, right? The challenges that we're facing today have been part of the supply chain for many years. But the reality here in 2021 is that these are becoming much, much more widespread. Where we used to have very specific instances where we'd have counterfeit components or bad components coming in, it's becoming more and more and more common, right? And again, this is a supply-demand problem. Whenever you have much less supply than you have demand, not only are the good actors going to try and meet that demand, but bad actors will also try to do the same thing. So what can you do? Well, the most important thing you can do if you are a maker or you're somebody who's trying to develop products for your customers, right? You need to make sure that you trust the people that are running your supply chain. You need to make sure that you trust the people that are purchasing your components to have the right processes in place, to have the right systems in place where they can not only make sure that they're procuring good components for you, but that they're also checking those components on a regular basis to make sure that these are not only coming from the right place, that they have the right provenance, but that they're being stored correctly, that they're being managed correctly, that they're being treated with the same care that you treat your customers and the products that you send to your customers. So with that, I'm out. I would love to hear from you guys. Just send us a note, ping us down in the comments. We'd love to hear from you guys. So I appreciate everybody's time, and I hope everybody does well this year in making all the devices that they need to make.